Welcome to this video. My name is DARSHAN KATGERI and I'm working with JCE College of Engineering, Belgaum. In this video, we will be studying in general about CAD and computer graphics softwares. It is important to understand about computer graphics software because these are very important because these softwares help us to increase the productivity, help us to save a lot of time and effort. Right? Owing to the importance of these softwares, it becomes very important to study about these softwares and their role in designing various products. Right? There are so many softwares that are available in the market. Like for example, we have SolidWorks, we have Autodesk Inventor, we have there's a CATIA, right? And these are only a few. So by making use of these softwares, we can create models, we can do analysis on these models, and finally the documentation can also be done by these softwares. Let us move on and see what are the various features of these softwares. But even before that, we should know about the design process. What is the process? What are the various stages involved in the process? In this next slide, we are going to study about the design process. That is, in this slide, we will study about the design process. So here you can see we have one diagram and a brief explanation about what each of these means is given here. So let us try to understand all of these stages, you can say, one by one. As we all know that need is the mother of invention. So the first step is recognition of the need or identifying the need. So what does this involve? It involves realization that there is a problem, right? And that problem can be solved by a thoughtful design, right? So identifying the problem is the first step, right? So everything starts from identifying the problem, that is nothing but recognition of the need. Like for example, let us try to understand this with a simple example wherein we will understand this with a simple example of software. Like for example, we have a simple software like MS Paint, right? And then we have a little more advanced softwares like Corel Draw, which used to be used extensively. And then we have very high-end softwares like we have Autodesk Maya, we have 3ds Max, and we have open source software like Blender. So what is the need of all these softwares? That is what we will see. So there could be a set of people whose need could be a very basic need in terms of the product that is required. They may want to draw a few lines, they may want to fill in some colors, and they may want to do some basic editing. So software like a Paint is sufficient for them, right? Wherein basic editing and some coloring suffices the need. But there could be another set of people who might require advanced features. They might want more control on the drawing that they are doing using these softwares. So they may want Bezier curves, they may want the control vertices, control vertex, which can be controlled, which will help them to generate a more organic kind of a look that is desired in the drawings. And that might be very difficult to obtain by using softwares like Paint, right? So these people require a different type of software which gives them more control on whatever they are doing. So there is a need for development of another software which will suffice their needs. So that is why we have softwares that cater to their requirements, right? So the first set of people have very basic need which will suffice by a simple software like paint. Another set of people, they have a little more advanced feature requirement which has to be provided to them, wherein we can also have people who need complete control on whatever they are doing, like for example, in film making or entertainment industry, especially I am talking about computer generated imagery, CGI animation movies and all those things, wherein the requirement is very demanding in the sense there are so many things that have to be there in the software, right from modeling, wherein the character or any product has to be modeled first. Then there is texturing means giving it a look and feel of whatever is desired. Then if we have characters, then we have to do skinning, and then we have to do rigging, and then we have finally animation. So the requirement of these people is completely different, right? And all of these is put together and it is designed as an software package. Like for example, you have Max, 3ds Max, you have Autodesk Maya, we have an open source blender. There are many softwares that cater to this particular need. So in the mechanical engineering, it could be a simple product or it could be a complex product, wherein the needs could be a little different, right? Whenever the need is simple, it can always be answered by developing a simple product. Whenever there is a complex need, the design usually becomes very challenging for the designer. So in short, there has to be a need, and whenever there is a need, some solution has to be thought about how this particular need can be met. So once we have the need, next we have the problem definition. Now what does this involve? This involves specification of the items to be designed. So what are the various things that are required to be done in the sense in designing this, like for example the physical characteristics, function, for what reason it is being designed. So all of this have to be defined in this particular stage, that is the problem definition stage. It involves functions, costs, or the quality, operating conditions, and performance. So all of these things, they have to be defined in this particular stage, that is the problem definition stage. Next, we move on to these two stages, which kind of go hand in hand. They are nothing but synthesis and analysis and optimization. Let us try to just go through this and understand. Synthesis and analysis, they are very closely related. So you can see that we have put up this particular bracket showing that they go hand in hand. So they are very closely related and they are highly interactive, right? So each of this, that is each of the subsystems of the product, it must be conceptualized by the designer. So the designer who is involved in this design process has to completely understand the need, has to properly understand the problem definition, and then he has to conceptualize whatever is required, and it might involve a lot of analysis, right? Analysis might give certain results. These results may be analyzed a little bit, and then if there is some improvement that has to be incorporated, it has to be incorporated, and thus the design has to be improved, and it might require to completely redesign sometimes. So it is very challenging as far as the engineering aspect of this is concerned, and these two stages are very important. And optimization, finally, uh, when we come up with a particular solution, right, we always look for optimized solution. As engineers, we always look for optimized solutions. That is, we don't want minimization or maximization, but we want a balance between all of these. So as a design engineer, he always tries to attempt to give an balanced solution to this particular problems. So this is a very challenging phase. That is a lot of thought and brainstorming has to be put in these particular stages. Also, some sort of brainstorming is required in problem definition and understanding the needs and all those things. Next, we come to this phase, that is evaluation. Once we have synthesized and analyzed, the next phase is concerned with measuring the design, right? Measuring the design means now we are going to evaluate what we have done, whether is it meeting the specifications that have been established in the problem definition phase. Has everything gone in well? So all of these things, it can be very well understood in this particular phase of evaluation. Evaluation ultimately means that we are uh, we are concerned with measuring the design, right? So a lot of tests may have to be carried out in this particular phase, and all of these tests have to be satisfactory. If they are not satisfactory, then again you have to go back to the synthesis. If the tests are not satisfactory, again you have to go back to the synthesis phase, and then make some changes. The changes could be minor changes, they could be major changes. If they are minor, then fine. If they are major changes, then again it is a challenging situation for the engineer, and again it comes back, again it has to be analyzed and then optimized. So this these three things, right, they are very closely related, right? So all of this has to be done step by step, one after the other. Then after all of these things have done, when things are now ready, then the last phase is about presentation, wherein it is concerned more about documentation of the design in terms of various drawings. The drawings could be production drawings, material specifications, and assemblies, and the to-do lists, uh, and various other reports, maybe for example uh, manufacturing considerations that should be taken care, and so many things that are involved in this particular process. So everything starts with a need, and then we go by the problem definition, and then we synthesize the things. Synthesize and analysis are two things that go hand in hand, and then there should be a balance that has to be strike between these two. That is where optimization comes into picture, and then all of these things have to be measured, which is done in the evaluation phase. And then finally we are coming into this presentation phase, wherein a lot of documentation has to be done. So this complete process is nothing but the design process. This is very important, right? So once we now understand this design process, the next question is how this CAD is going to help us to do all of this process, that is the design process, which is explained in this particular slide. So here we see what is the definition of CAD. By CAD we actually mean computer aided design, right? And it is defined as any design activity that involves use of computers, right? So why we are using computers is to create, to analyze, to optimize, and finally document an engineering design. So you can see that all of these phases or stages, these are the stages that we have already seen in the design process in the previous slide. Uh, to this we are adding this CAD, right? So you can see here in this white box, we have CAD. What exactly is this CAD, or computer aided design, or how it can be done by using computers, is what we will see next. So here we see that there are four things involved in this. The first one is geometric modeling, and then we have analysis, engineering analysis. And after we do analysis, then we have to review and evaluate the design. And finally, we have to do drafting, which will be done by using computers. That is why it is automated drafting. So all of this, it comprises CAD, and you can see that there are connections. That is a synthesis of geometric model and analysis of analysis and evaluation of the design. It is done by using computers and various softwares. Like for example, we have so many softwares in the market. Some of them exclusively are modeling softwares. Some of them are modeling and analysis softwares. To name a few softwares, we have softwares that are given by Dassault system, Dassault systems, which we call it as. We have CATIA, we have SolidWorks from Dassault systems, and then we have Inventor, Autodesk Inventor. Then we have so many softwares that can be used for designing and analysis, designing in the sense modeling, and then analyzing these particular products. So one of the software is CATIA. So let me tell you something about CATIA. CATIA is a software which is given by Dassault Systems, as stated earlier. The full form of CATIA is Computer Aided Interactive Three-Dimensional Interactive Application. Computer Aided Three-Dimensional Interactive Application, which is abbreviated as CATIA. So it's a software which is which by using which you can keep a track of the product right from its inception to its disposal. That is from the starting till the end. I am talking about disposal because many a times it is important uh, to keep a track of how a particular material, like hazardous materials, are disposed. So that is why disposal also becomes important at times. So we can keep a track of a particular product right from its inception to its disposal, and all of this can be done by using a software like CATIA. Now in CATIA there are so many modules for say civil engineering. Also we can model electrical engineering, and do a lot of electrical analysis on those particular products. But for mechanical, we basically go for part design in CATIA, wherein we model the part, and we can also do some basic kind of analysis in this particular software. And then we can also do NC manufacturing. That is, we can generate the G codes and M codes by using this particular software. So in general, to talk, It is an complete package in which you can do almost everything that is important or that has to be done in engineering design. Also, it has various modules, and also you can do collaboration. Collaboration is basically a communication which is important. Say I am working for somewhere from India, and I am working with a team which is outside India, like for example, say America. So in that case, we may have to collaborate with each other because we are working on the same product. So there is a lot of communication that has to be established, and all of this can be done by using software like CATIA. It is a complete package. It's a PLM software wherein you can keep track of the product life cycle of a particular product, which is quite commendable. And by using these softwares, thus with so much of facilities provided in the software, we can easily increase the productivity. We can save a lot of time and effort by using these softwares. Here in this CAD, we see that we have geometric modeling, engineering analysis, design, review and evaluation, and automated drafting. All of these things I will be explaining in the next video. So this session we will end it now. Thank you.